All right, let's dive into one of the most mind-bending connections in all of mathematics. We're talking about a hidden law, a secret rule that ties together two things that could not be more opposite: the perfect, predictable order of prime numbers and the absolute chaos of pure chance. It sounds impossible, right? But it turns out to reveal something incredibly deep about how the universe is put together.
So just think about it. On one side, you have the prime numbers. They are the atoms of arithmetic, the bedrock of mathematics. Each one is fixed, eternal. They follow a pattern, even if we don't fully understand it. And on the other side, pure chaos. Imagine a speck of dust floating in a sunbeam or a particle jiggling around in a liquid. It's a random walk with no memory, no future plan. They are, for all intents and purposes, mathematical opposites.
But what if that whole idea is just wrong? What if these two completely different worlds, the world of absolute certainty and the world of pure randomness, are actually just two sides of the very same coin? What if they're governed by the exact same deep mathematical law? Well, that's the wild mystery we're going to unravel. Okay, so to even begin to understand this, we've got to start with one side of the coin, the search for order. For centuries, mathematicians have been obsessed with the primes. They needed a map, some kind of tool that could predict where these fundamental numbers would show up on the number line. And that map, well, it's the legendary Riemann zeta function. The best way to think about it is like a treasure map for the primes. The X that marks the spot is something mathematicians call a zero. And here's the crazy part. The most famous unsolved problem in all of math, the Riemann hypothesis, basically says that all the important treasure, all those zeros, lie on one single, perfectly straight line. Now, you have to understand, this hunt for certainty wasn't happening in some quiet library. At the time, mathematics was going through a total identity crisis. You had brilliant minds like Cantor discovering that some infinities are bigger than others, which just broke everyone's brain. Then Gödel proved that some things in math are true, but we can never, ever prove them. The very foundations were cracking. So this quest to map the primes became part of this bigger, desperate search for some kind of order in a newly chaotic mathematical world. All right, let's put a pin in the world of order for a second. Now we're going to flip to the complete other side of the story. While some mathematicians were desperately trying to build rigid structures, a whole other group was creating a language to describe the exact opposite: pure, unadulterated chance. The absolute gold standard for chaos? It's something called Brownian motion. You've seen it, that speck of dust dancing in the air, or the chaotic up and down of the stock market. Mathematicians have this great name for it: a drunken sailor's walk. It's a path so random, it has zero memory of where it's been and no clue where it's going next. It is the perfect mathematical picture of unpredictability. So there you have it. Two totally separate mathematical universes. The perfect, rigid order of the primes on one side and the total chaos of a random walk on the other. For the better part of a century, nobody even dreamed they could be related. And then came the detectives who saw a hidden bridge. Our first detective is one of the most incredible minds in history, Srinivasa Ramanujan. He was a self-taught genius from India who didn't really do formal proofs. He worked on pure intuition, like he was downloading truths from somewhere else. He'd write down these unbelievably complex formulas, and his collaborator, the famous G.H. Hardy, basically said, look, these have to be true because no human being has enough imagination to have just made them up. And this intuition, it led to results that were just mind-bending. For instance, Ramanujan and Hardy worked out a formula to predict a hugely complex number, the number of ways you can add up whole numbers to get 200. And when they ran the calculation, their answer was off by only 4,000th. An error that tiny for a problem that complex, it was like a whisper from the universe that there was some deep, hidden structure they were tapping into. Ramanujan had the lightning in a bottle insight, right? The vision. But it took almost a century for formal mathematics to catch up and prove he was right. That final step happened in 2001, when three mathematicians, Bion, Pitman, and Yor, finally built the solid logical bridge that officially connected Ramanujan's strange ideas about numbers to the world of randomness and probability theory. So, how on earth did they do it? Let's get into the evidence. This is the moment, the Rosetta Stone, that finally lets us translate the language of pure chaos into the language of the prime numbers. Okay, this is the heart of the whole discovery, and it is just brilliant. Imagine one of those random walks, but you force it to start at zero, and after all its wandering end up back at zero. They call that a Brownian bridge. Now, you look at all the possible random paths it could take, and you measure one simple thing, the total up and down distance it traveled. And here's the absolute magic. When you calculate the probabilities for all those possible distances, the formula that perfectly describes that probability is the Riemann zeta function. The map to the primes was hiding inside a random walk the whole time. It's unbelievable. Now, the technical gear that does all this heavy lifting is called the Mellin transform. You don't need to get bogged down in the details, just think of it like a universal translator. It takes the statistical rules of randomness, puts them in one end, and out the other end comes the precise analytical laws of the prime numbers. It's the decoder ring for these two different worlds. But here's the thing, this connection isn't just about some abstract formula. The really stunning part is that this connection reveals a hidden geometry, a visual link that you can actually see between these two worlds. In this hidden geometry, it's not random. It's actually encoded with some of the most fundamental, most important numbers in all of math and physics. I mean, look at this. You have special primes that allow for incredible geometric constructions. You have others that are deeply tied to things like the fine structure constant, one of the key numbers that governs our physical universe. These numbers aren't just a coincidence. They are like the structural pillars holding this entire mathematical bridge up. And visually, this is where it all comes together in a way that's just beautiful. That famous critical line where everyone's hunting for the zeros of the zeta function, it's not just a line. It's actually the path of this intricate, endless spiral. It just keeps looping around, and every single time that spiral passes through the center point, boom, it pinpoints crucial information about where the prime numbers are. So you might be thinking, okay, that's a really cool math trick, but it's so much more than that. This hidden connection is like finding a cosmic blueprint, a fundamental pattern that we are now starting to see echoed across all different kinds of science. I mean, this blueprint has seriously profound implications. In quantum physics, scientists have found that the spacing between the zeta function zeros perfectly mirrors the energy levels in chaotic atomic systems. The primes are literally singing the song of the subatomic world. The same math is helping to forecast financial markets, and maybe most exciting of all, it gives mathematicians a brand new, powerful set of tools to finally try and prove the Riemann hypothesis. It's just another stunning example of what physicists call the unreasonable effectiveness of mathematics. It's this weird phenomenon where a deep, abstract truth you discover in one corner of reality, like the world of pure numbers, turns out to be the exact blueprint you needed to understand a completely different corner of reality. It means the atoms of arithmetic and a random speck of dust are, in some deep way, dancing to the very same music. And that really brings us to the big, final question, the thought I want to leave you with. If the most perfect order we can conceive of, the primes, and the most perfect chaos we can imagine, a random walk, are actually governed by the same deep law, then what does that say about reality itself? Maybe that hard line we like to draw between order and chaos isn't really there. Maybe it's just an illusion, just our limited perspective on a single, unified, and absolutely beautiful whole.